So the data center facility space has evolved at a tremendous pace in the last decade or so. The business of cloud services, digital services rollouts, IoT that is coming on board, the whole readiness that clients are looking for AI and automation-based applications is putting tremendous pressure on the whole data center facility. From a pure size point of view, the data center has gone from a few megawatts to tens of megawatts. From an availability point of view, the data center is now expected to run some very mission-critical services, and so availability is at its premium. The speed at which IT is evolving is putting a lot of unpredictability in this whole space. It's very difficult to predict what will come in the data center in terms of densities, in terms of availability in the coming few years. So when you put all of this together, the data center operators, data center owners are facing very unique pressures. They are expected to bring services up online in the shortest possible time. They need to invest as much as possible in a manner that gives them the best return on capital employed. They want to find technologies which reduces their OpEx as much as possible. And they still need to factor in all the unpredictability of the data center business. So all of this is in many different ways forcing data center technology providers to come up with unique, innovative solutions. If you then expand the envelope of data centers, given the new technologies of IoT, AI-based systems, these are now bringing on board requirements where you need much lower latencies, you need much more forward processing of data, which requires now data centers being spread out not only at the back end at the core, but also on the front side at the edge. Edge demands are again very unique. Real estate is at a premium. You need the shortest possible footprint. You need them to be readily deployed and at the same time at the best possible TCO. So that would pretty much summarize the challenges and the new trends in the data center space. There is a very old saying, if it's working, don't touch it and don't try to fix it. What this does is pretty much with the kind of availability that is required from data centers, almost all the elements in the data center are very mission critical, namely power and cooling. Both of these also are the single largest OpEx of the data center. Especially when you look at a data center operating over a period of an annual calendar. Across the different seasonal cycles, the weather changes. Across different daily, monthly operational load cycles. None of these are constant. However, the set points of the data center are usually constant. And the operating parameters and the cycles that are set up are very constant. And this, in many ways, creates an operational play where you are, in most cases, consuming more energy than you should be. So there is a major entitlement here in terms of energy saving, especially on the cooling side. So rather than having human operators who start playing around with the controls, this can be solved with a lot of AI-based automation, where you could have multiple variables being measured, recorded, studied, and then you train the operating models to learn as to how to operate given those various conditions, whether it's temperature, humidity on the external environment, load, internal temperatures on the inside environment, and so on and so forth. Some of the models that have been trained nowadays are able to bring down cooling consumption or power consumption for cooling by as much as 10 to 15 to 20%. So that's one aspect of the OpEx in the data center on the energy saving side. The other aspect is data centers today have thousands, if not tens of thousands of equipment. And maintaining, managing all this equipment is a challenge. Again, automation definitely allows far more predictability, consistency, a process-driven approach towards managing your complete data center infrastructure. And so leveraging this automation is helping us in two areas. One, it's helping us to create a much more reliable operation, but more importantly, it's also able to help us to reduce the human cost in the data center. So certain practices actually allow you to increase the number of racks per data center personnel. So not so long ago, it was very common to have one data center personnel per 100 racks. Now this number has grown up to 400, 500 racks per person. So again, AI and automation is helping a lot in improving the quality, the performance, and the cost of operating data centers. So what's very interesting at Huawei is we cut across both the telecom carrier business and the enterprise business. And most of these customers look at very short time to market. Most of these customers are deploying data centers across various geographies, so they're looking for consistency in quality and delivery. And almost all of them are looking at much smarter and lower TCO-based operating systems. So at Huawei, we have over the last 24-36 months evolved what we call the prefab data center approach. Today we are able to build turnkey data centers from 1 megawatt to 8-10 megawatts, from a few hundred racks to a few thousand racks in less than 12 months. What that is allowing our customers is it's giving them a much better time to market, therefore a much better return on capital employed, and more importantly, much early to market so they can sell their services ahead of their competition. The second aspect we are focused on is to help reduce the cost. As you increase the size of the data centers, you're looking at megawatts of UPS requirements. When you approach this megawatts of UPS requirements, you end up having multiple UPSs, a few dozen UPSs in that environment. All of these UPS then need interconnections which increase their cost and time to deploy. So at Huawei, we have re-architected the whole UPS frame. Today we have put together UPS frames at 1.6 megawatts per frame. This is pretty much twice of what is normally available in the industry. What this has done is helped us to reduce the footprint, helps us reduce the time, and helped us and our clients to reduce their cost. So this further adds to the benefit that the customer can derive from the data center. And then thirdly is, more importantly, the AI-enabled DCIM. Today, our DCIM has an extra layer of artificial intelligence-based training, which helps on 3 different layers of the data center. It focuses on the power side to make sure all information is available, and there is necessary training so that all of this information that is collected can be observed carefully, and you can have predictive analytics done on that. So you can foresee problems before they happen and accordingly do predictive maintenance instead of regular preventive maintenance. On the cooling side, as I mentioned before, this is helping us to train the control algorithms in such a way that we are able to monitor and move the variables, whether they are fan speeds, pump speeds, compressor speeds, and that allows us to get the best operating point for any given hour within the whole annual cycle of the data center, irrespective of the load cycles. So this is helping us to reduce the PUE by anywhere between 15 to 20% for pretty much any operating condition. So that's the second key thing that we're doing at Huawei. And finally, the AI-enabled automation, which allows us to understand the utilization of the use space, utilization of power, cooling, utilization and lifecycle management of different devices, and all of this on a unified platform, which allows an operator to see not one, not two, but almost all his data centers on a single dashboard, ability to create value in terms of engaging with his current clients, his future clients, his existing operational teams, and this is all helping our clients in many different ways, and is bringing value to them and is helping them to make decisions which would benefit their business.